I can't remember how many times I've been here. And even in this room, I think I've been in this room a lot. So at least probably 5 times in the EclipseCon. So today I'm going to talk about hybrid cloud application development with pure openness. So this is talk I actually generated from one conversation at a conference. Basically, the one developer came over to me and said, oh, Emily, it's like we are trying to move to the cloud. However, we don't really want to tie it with any particular cloud. So it's my employer might change, go to different cloud, and but I wouldn't want to change my application. So, and then here it goes. So in today's talk, hopefully what I have been showing you is not particularly related to any cloud. Your application, once it's built in this way, it can deploy to any cloud. And also I will talk about basically is how can you go to serverless for your Jakarta EE applications. So I'm talking about hybrid cloud, and then I will talk a little bit about microprofile Jakarta and Jakarta EE, and also talk about one implementation of these 2 technologies, Open Liberty, and then I will give you a demo. Basically, I will demo how to basically easily to use microprofile and Jakarta EE with some tooling, and then tell you how to basically make this application basically to go serverless. So first is a hybrid cloud. You talk about basically a lot of cloud. It's Amazon cloud, Azure cloud, Google cloud, and etc. So they are all public cloud. Hybrid cloud means you have both private cloud and public cloud. Actually, this is a hybrid cloud is everywhere. Most companies, they will have both private cloud and public cloud. So it's, you need to make sure your application can deploy in both. So here it goes, is a hybrid cloud. And then you might also heard about multi-cloud. Multi-cloud basically is a different flavor of cloud. Doesn't really necessarily means you have both private and public. And mainly is refer to multiple public cloud. So this is a hybrid cloud. For hybrid cloud applications, so basically they are cloud native applications. And as you know, most of us are doing microservices nowadays. Do you all doing microservices at the moment? Okay, great. So anyway, if you are not doing microservices, monoliths can also go to cloud native. But basically, you can use Jakarta EE and microprofile technologies to make a particular portion of the monoliths to be cloud native. This is what I mentioned about openness. So basically, it's open technologies. You can freely accessible in the internet. So it's free to you. So this is kind of the openness. I think it's probably all of you know Jakarta EE. Jakarta EE. Who knows Jakarta EE? Okay, that's great. Who knows microprofile? Okay, most of you, that's good. And for Jakarta EE, I think I will not talk too much about Jakarta EE. However, I just touch on the major point. So it's now Jakarta EE. When you think of Jakarta EE, do not think about old traditional Java EE. Actually, Jakarta EE nowadays also geared towards cloud native. And also, basically, we're trying to encourage more innovations. And later on this week, and do you all stay for the whole duration of this conference? Okay, a few, okay. So if you stay for the duration conference, check out the talk about Jakarta data, and also Eva is going to do a more in-depth Jakarta EE talk later this week. Check it out. So it's Jakarta EE basically is supported by a lot members. IBM is also Oracle, Tommy 12, Jisoo, Piara is a strategic member, and Microsoft and Red Hat, and 2 other Chinese companies, enterprise member. As you can see, IJAC is IJAC, yeah, over there, participant member. So it's basically it's embraced by the community. So it's a great foundation here. And the latest release, Jakarta EE10, you can see it has over 30 specifications. That's kind of last year's release. And then now we're trying to do preparing for Jakarta EE11 release. So this is a web profile. Do you all use the Jakarta EE10? Anybody? Okay, one. Anybody use Jakarta EE? Okay, if you are not, try it out. It's great. Anyway, later I will give you a quick demo. So this is a kind of is a cut-down version of the web profile. We call it a core profile. So it was created by macro profile usage. So it has Jakarta REST, JSON P, JSON B, annotations, interceptor, and CDI light, and also with indirectly pull in the dependency injection. Okay, I think a macro profile, so this audience kind of has less exposure to macro profile. So macro profile actually was created in the, basically it's 2016. So at that time, Java EE basically stopped any innovation, stopped any releases. So some members, IBM, Red Hat, Tommy Choi, Piara, and others came together and launched a Java group. And we established the macro profile. And then in the January 2017, I moved to Eclipse Foundation. And because of this, and then that triggered the Jakarta EE being born. So it's basically the Oracle eventually also donate Java EE to Eclipse Foundation and then become Jakarta EE. So this is really hot new release, macro profile 6.1. It released like yesterday, but it's going to be marketed either today and tomorrow. So macro profile 6.1. So this is the latest macro profile releases. So you have a telemetry, 1.1 Open API, REST client. So that's 8 specifications together with the Jakarta EE10 core profile. And this is the outside umbrella. If you do reactive, you have reactive messaging, reactive stream operators, and transaction, LRA, GraphQL, and also the context propagation. So this is kind of the up-to-date, current macro profile offer available to you. So this is the kind of the latest. As you can see, what's in the Jakarta EE10 core profile is also included. So this busy chart shows how how quickly macro profile has been released since 2016. So it's from the 2016 back to 2023. So it's is always based on Jakarta technologies. And previously, it's Java EE and Jakarta EE technologies. So here you go. It's similar to Jakarta EE. Macro profile also has a working group. So it has 12 working group members. Have IBM, Red Hat, Tommy Choi, and AJAC, and Microsoft, Oracle, IJAC, and also is a few other JACs. And there's many implementations as well, but it's in today's talk, I will use a macro profile as an implementation for Jakarta and a macro profile. So also it has a compatible implementations. Basically, the compatible implementations they have to pass all the TCKs published by macro profile. So that's why you can see the if you use macro profile 6, you can choose like these 3 implementations. And because once you use macro profile 6, you can move around between these compatible implementations, and your program will continue work without any problems. But see, some other runtime is catching up with the latest releases. Okay, next one is I'm introduce OpenLiberty. Anybody know OpenLiberty? Okay, a few, great. So OpenLiberty is the implementation, is one of the implementation for macro profile and Jakarta EE. And also the people are asking, like, because there's multiple implementations for macro profile and Jakarta EE. So this is, okay, they all implement the same API. How can they compete with each other? So the competition is pretty much through the tooling, through the performance. So that's pretty much. However, this is a great ecosystem and a great way to run the business, right? We come together and put innovation together to benefit end user. For you, you only need to know the APIs, and then once you finish off your coding, your deployment team can choose some like a different runtime to deploy it. But so for OpenLiberty, it basically is implement these APIs and also give you greater tooling for you to develop your coding and etc. So I will have a quick demo later. So as you can see, one thing I want to emphasize is OpenLiberty fully embraces these open source technologies, macroprofile and Jakarta EE, and trying to keep up to date with the releases. So this is great. Actually, we encourage, basically I encourage all the implementations stay up to date with the specification. Only with this, basically, you can move the implementation effort forward and also benefit the whole end user community as well. So this is give you a quick, basically, overview. Yeah, so this is a kind of OpenLiberty is basically we trying not to do vendor lock-in. So it's trying to just put all the innovation in the open source community. So it's basically just advertise the open standard so that you don't do a vendor lock-in. So it's one thing is that I want to just quickly go through the OpenLiberty's feature. So it's OpenLiberty just give you like enough runtime to run your application. So it's basically if you just want to use REST, you just give you the building block to run the REST. And also it's kind of it has a continuous delivery. Every 4 weeks, OpenLiberty has a release. And also it has zero migration, which is different from all the other runtime. So it's in OpenLiberty, all the releases, the latest releases, support every version of macro profile. It's basically it does not remove the older version macro profile, and also support the Jakarta EE versions from Jakarta EE. From Java EE 7 and to all the Jakarta EE versions. So you don't have the migration headache. You can stay current with your Java technologies and also the security fixes, but your application can stay on like a early version of the macro profile Jakarta EE. And also it has really nice tooling for Kubernetes support, and also has a great developer experience. So I will show you in a minute. The first thing is the right size deployment. So this is, I want to explain this kind of how the OpenLiberty works. So it's anybody know WebSphere? Okay, that's good. WebSphere basically give you everything, no matter you use it or not. And also some other runtime also give you the whole thing, no matter whether you use it or not. However, in Liberty, it has a lot of building blocks. It has a kernel, so kernel is basically the backbone. And then it has some like building blocks, like Lego blocks. If you say, okay, in the future you control, you say, okay, I want to use the Jakarta technology CDI. It just give you the 2 building blocks to support CDI. If you say you want to use the Jakarta RESTful web services, and they give you this one. So that's why the how is basically control the size. The implementation itself is using OSGI. Anybody know OSGI? Yeah, so this is the red audience here. So we use OSGI basically is to load the runtime, also does the version control. For the right size, for the like a tooling support, actually it has a Maven grid support. Also, it has a container build. So as you can see here, you can do when you do your Docker image, Docker file. So the first line just tell you like the base image, Open Liberty, is in the ICR, means IBM container registry, and also it's available on Docker image, Docker Hub as well. And then you can specify like Java version as OpenJ9. Anybody know OpenJ9? Yeah, so that's great. So you can see here, use the OpenJ9 Java 17 UBM image, and then you can run the feature.sh. So this line will just give you the right building blocks. And then you can run, copy your WAR file, run the config.sh. So that will be optimized execution in the Docker container. So this is kind of the that one. For the CI/CD, basically, you from a plan to the monitor there's a different support from the tooling, build, test, release, and etc. So every 4 weeks do the release, and also it's kind of there's a lot tooling support for different stages. As you can see, for the developer efficiency, so there's IDE. I will demo to see there's a code assistant, and also for the Jakarta and macro profile usage, and also is some other plugins for you to use, and also you can easily to debug it. And also is when you consider containerization, one technology you might want to learn is operator. Anybody know operator? Okay, that's great. So if you do not know operator, so when you deploy to the cloud, you will need to basically create your deployment YAML file. In that YAML file, you need to do basically the deployment and also the services, right? And however is YAML, you need to write, copy all the things, and wear your glasses to watch the spaces, right? And with the Kubernetes, with the operator, so you don't need to do all the deployment or services. It directly just do everything for you. All you need to provide is the application image. So this is across the board. So it's all the operators should behave like that. So this is kind of the operator. If you use Open Liberty, there's an Open Liberty operator. And also you can get from most cloud. The other things for the observability I want to touch on is very fundamental for the cloud native applications. So there's 4 pillars. Logging. You will definitely need a login. You either use Log4j or use the like a Java logging. So it's a Java like Java utility logging. And for metrics, for the metrics, and we highly recommend basically the macro profile metrics. Heiko, they are very smile. If you have any questions about macro profile metrics, Heiko is the man. Heiko originally initiated this one. Anybody know macro profile matrix? Okay, great. So so that's a matrix. You can get a lot of matrix from there, and also the health. So this is the macro profile health. So give you the the health status about liveness, readiness, or startup, later on. So this is directly hooked into the Kubernetes liveness check, liveness probe, and readiness probe, and also startup probe. And the fourth pillar, which is tracing. Tracing is very fundamental because when you deploy your application in the cloud, if something goes wrong, you need to work out why it's not working. And also, if it's the slow response, you need to find out where the time was spent. So this tracing is very important. So for the tracing is basically highly recommend you use microprofile telemetry tracing. That's based on the open telemetry, basically tracing. Anybody know open telemetry? Okay, so that's under CNCF. Actually, is second most popular project in CNCF. So it's a lot of industry leaders and also companies came together to evolve this open telemetry. And both Jiang and I work on the open telemetry, micro-profile telemetry tracing. So basically later on, we start with the tracing first, and then we gradually also adopt the open telemetry metrics and logging and etc. So it's for the tracing, you can have basically automatic tracing or manual tracing or the Java agent tracing. It's very easy to use. I will demo a little bit later on. Okay, it's demo time. So I will just use Open Liberty to show you how easy to get started with basically macro profile and Jakarta EE, and then just build your microservices. So with that, I use my actually, I want to generate basically application. This time I generate application, I use Open Liberty Starter. You can use macro profile starter as well. So Open Liberty, can you see okay? Clear? So here, I just let's say community day. I use the 11 and Jakarta, and the macro profile 6.1 just released today, so it's not, it's in the Open Liberty beta, but this is for the GA. So let me directly generate that. So I just start my IDE. So basically, he give me just one file, basically REST. So with the tooling, basically the Liberty, I have a Liberty tools installed here. I can start it. I can start in the background. As you can see here, it's already got a Docker file. And then I can create basically the REST. I can say REST resource. So basically, I want to create a REST application. Maybe just say hello. So I can say REST. So this is kind of give me automatically generate REST. So here I just say hello. Say hello, EclipseCon. And then I can save it. Because earlier I mentioned basically This is my macro profile decoder EE up. So I have these two features enabled. And I have in macro profile there's an open API. So it's if I do, because I have that feature enabled, if I do open API UI, see, I get all this UI automatically basically popped up. This is a kind of liberty. And then I can try it out. I can see try it out. Execute. See, it says hello EclipseCon. The other thing is if I go back, and then you can make a change now you can see community day. You save it, and it will pick up the changes straight away. You can execute. See, you can see the changes straight away. So I can just say microprofile decoder is a great cloud native basic technology. And there's a lot of tooling from different vendors to help you to create these applications. And now I mentioned briefly mentioned the mentioned the health, right? And then you can just even say, okay, I can create a health. So I can just say new file. Maybe I will say Lebanese check. And then I just say, okay, I control space. So Lebanese. And it create a Lebanese check for me. And then obviously here you do the Lebanese check logic. Maybe you check your RAM usage, etc. As is just say Eclipse. I save this, and then it automatically has the endpoint stand up for you. So localhost 9080, the health, and life. See, you can see, yeah, this changes straight away. So it's really, really easy to get started. With that, actually, also I want to quickly say the metrics. But at the moment, the metrics basically is has security, has basically is has the different endpoint. If I just say not authorized, so I can see the metrics go to the localhost 9080 metrics. See, you can see all the metrics, like CPU metrics, and also the basically execution metrics, session metrics. So it's if I just directly poke this and execute this again, you can see more metrics. See, you can get more like a REST core metrics, or the different scope and etc. So this is directly use macroprofile 6. So it's the macroprofile metrics 5. So it's the other thing is kind of the tracing. So at the moment, we don't have any tracing, because you have to enable tracing to in order to get a tracing. So with that, actually, I can basically can copy this. If I directly create a resource, resources, and then create another folder, meta-inf, and then I create a file. So basically, I want to set a configuration file, microprofile config.properties, and I want to enable tracing. You can see basically community day. So I will say is disabled equals false, and the trace exporter is Yaga, and the service name is community day. Now if I go back here, and I call this one again, and now I go back here. You can see community day, right? And see the tracing. I can find the traces. So you get this trace straight away. So you can only see one trace because it's only one microservice. So you have to create another one so you can see the span or correlated together. So this is basically a quick demo to see how easy to get started with macroprofile and GitHub. Let's go to extra level. And you might also like thinking about like a cloud deployment. So for cloud deployment, and then go even further to go to the serverless, right? Go to serverless. With the JVM, so Java is different from other like languages. It's one unique thing is there's a JVM. So JVM is in the middle. Basically, when you start an application, JVM has to do a lot of work. So there's a kind of CPU spike, there's a memory spike, just like it's make the performance sometimes suffer. So with that, people are considering is kind of Java suitable for the serverless. And as you can see here, like that's the OpenG9 client, the blue one. So you get a spike, especially the slow warm up. Is when you JVM very, very smart. Once is kind of go through the icebreaker period, right? It's warm up, it's really, really performant. However, that spike sometimes is not good for the application. And luckily, there's a kind of new initiative and a new technology called Sumeru Cloud Compiler. So do you know why there's a spike? Anybody? So the spike is because of JIT. JIT is there trying to speed up things. However, he also need to use the CPU and memory enable to speed up like some compilation. So because of this JIT, so that's why the Sumeru Cloud Compiler said, let's put a JIT in as a dedicated service, like basically it's a software as a service in the cloud, and deploy in the cloud. And then in the future, your application, when you need a JIT, do not use your own JIT and go to use the dedicated service. With that, you can see the yellow line. It's dedicated work. It's almost like an open source JIT. And then you got flat. Basically, you no longer get a spike. With that, you can see it save a lot of memory, and also is the less CPU usage. So that's called Sumeru Cloud Compiler. Anybody know is IBM Sumeru? Okay, that's good. It's built on the OpenG9, and also is because of the TCK license things. So IBM has to create the offering called Sumeru. So IBM Sumeru also open source. So you can freely download. There's an enterprise edition and also community edition. They are identical. The only difference, community edition is allowed to run the TCK. And the enterprise edition is allowed to run the JVM TCK, while the community edition doesn't run that, but binary is identical. So it's again, it's free. The other thing is That's got rid of the spike. The other thing is kind of the startup. Java is still like not as quick as other machine languages, right? It's like Python. Why Python is so fast? Because it's when you compile, it's compiled to a machine language, and then Java, when you compile, is still byte code. Still, JVM need to do some work to start that. And recently, there's a Linux technology called CRIU. Anybody heard of that? Okay, so that's good. A few of you. So basically, it's CRIU is a checkpoint in user space. So basically, it's the main kind of the concept is if everything starts up, you take a snapshot, and in the future, you do not need to start from code. You just use that image. So with this technology, basically, you just, when you create a Docker image, you warm up and take a snapshot. In the future, in the cloud, is you do not ever go from the code start. You always from the snapshot. So with that, like you do not need to load all the classes and create a cache and etc. You can get everything built for you. So with that, we did an experiment. So it's if your app start normally is in the basically 1 second. Now is 128 milliseconds. You can see a lot of time being cut off. So it's kind of reached up to 118 plus, basically these times. And if you have not heard of this technology, you might have heard of the GraalVM, right? Anybody? GraalVM? Yeah. GraalVM basically is a non-VM because it's basically is compile everything to machine code, and the JVM is not in the play anymore. With GraalVM, there's some a lot of Java instrumentation tools no longer work because that's all sealed up. You couldn't get into the JVM. There's no JVM for you to inspect. So there's a lot basically is shortcomings. But with this instant on, so basically is use the CRIU technology both in Sumeru and also in OpenLiberty. So it's still you have the real JVM to deal with, but you can get all the benefit. So I will give you a quick demo in a minute. So this is how Liberty Instant On works. Basically, as I mentioned earlier, you do the build. So basically, it's in the container build, and then you take a snapshot. And then if you need 5 instances, you directly install that instance straight away. So it's basically it uses this is Linux CRIU snapshot process, including memory pages and network connections. So this is how it works. So it's for the one I finish with is about a scale to 0. When you want to scale to 0, Knative is the tool normally help you to do the scale to 0. Knative, anybody know Knative? Okay, a few hands. So that's good. It has 3 pillars: building, serving, and eventing. So it has some tools, but we kind of focus on the serving pillar. So it's about how to use Knative to directly basically the scale to 0. So I will basically the Sumeru Cloud Compiler basically help you to reduce the CPU and memory spike, instant on, boost up your startup, Knative to scale to 0. They can all work together, so get your application basically running within milliseconds. So I will quickly give you a demo to finish off. So it's I have this machine app. So it's in this machine, it's basically is one microservice. So it's there's a kind of two images. So it's one is basically is run base and run instant on. If I basically run run base, as you can see, so this is without instant on. So it can start like in 4 seconds. Finish start. And if I run, it's instant on. So this is start 467 milliseconds. And then everything is still work. So if I directly copy this. So you can see this is just this application print the system properties. And also, so this is kind of in the Docker container. And also it has knative capability. If I just say get ports, let me make it bigger. So you can see it's just like this is knative service. It's because no load, no workload, so other service is not working. But if you see, if I do get key, you can see these two like services is actually is waiting to serve the request. So this one is no instant on. So this is directly if I poke that endpoint. If I just say this, you can watch how look at what here is from the code to get the response, and it will take a look. It's not suitable for the serverless like a load. However, if I do the instant on, see, it's a huge difference. I mean, the finally, so this box basically has all of them like a knative instant on and everything, and work together. If you look at the YAML file, so you can see it's really, really easy. This uses the basically is just specify the image, and you just set some rule like cloud compiler. Just that 3 line, you get everything. So if you just say get key service, you can see this is kind of that's an application with some root cloud compiler, and then that's the same application. If I do this, see, you can see you get the same application up running. So that's with some root cloud compiler. So you can see the 3 instances summary, and with that, I think that's all I have. Yeah, so this is useful resources for you to, to look it up. That's kind of summarized my today's talk. Yeah, thanks.
Thanks, Emily, for giving us an update on what's the state right now, and looks very, very promising. Even Graal VM is now outdated, kind of. No, it's like a good competition between these technologies. I think there might be some questions even.
Yeah.
I see there one, and might I offer you the microphone, because then questions are very important, And sorry, for the recordings, it would be great.
Thank you very much for the presentation. I have a question for the first demo, and since we were talking about vendor lock-in, so how complex would it be to migrate it to another microprofile implementation, let's say Quarkus? So what do I need to do? What is the complexity?
Yeah, very, very good question. So all you need to do, if you do a Maven project, so it's pretty much currently in the POM, I have the Open Liberty plugin, and if you use Quarkus, that would be you use a Quarkus plugin. And for the API, I can show you. So you can see here, right? Yeah, you can see. So here, like you can see the dependency is same, right? Yeah. So and the Maven Wall plugin, so always here. See, this is how short the POM. Can see nothing else. So in here we say, okay, I want to Open Liberty plugin, and then you just need to replace with the Quarkus plugin, and it is even more simple. Nowadays, vendors most of them have a starter. Quarkus also give you a starter, right? You can just, if you create an application, for example, on Open Liberty, you have all the Java classes, you do not need to change that. You pretty much replace your POM. Yeah, that's a standard. Microprofile config property is from microprofile config. Yeah, your server XML is for Liberty. And then Quarkus, you use a different way to control which feature.
Yeah.
Yeah.
So basically, it's the still proprietary things like the server.xml, which we turn into application properties, but everything, the microprofile APIs, the microprofile config, that's all standard, that's used across all these servers. We have demoed that in the past here, that we had this very same application running on 3 or 4 different machines or servers on the very same laptop. So it's really this little bit of surrounding things, also like the logger, which is not yet standardized in microprofile because logging is just too complicated to get it ever standardized. But everything else is really the same across all the servers.
Okay.
Yeah.
I
Thank you.
don't want to cut it off. In contrast, I'd ask you to continue the discussion. It's a great community discussion. I think Emily will be around today, and everybody else.
Whole week. I'll be here whole week. Oh, by the way, yeah.
Great. Okay. So continue the discussion, please. And I want to give the time to the next speaker to prepare. And again, thanks a lot, Emily, for your great talk.